When we're multiplying, there are some patterns and shortcuts that are just kind of neat to know about. I want to make sure we're comfortable working with them. So let's take a look here at what it means when you have a set of parentheses raised to a power. Remember that a power just means you multiply something times itself that number of times. So 8.3x to the third in parentheses to the power of 2 just means this. 8.3x to the third times another 8.3x to the third. That's it. So it means take 8.3 times 8.3, which is 68.89, and take x to the third times another x to the third, which should leave you with x to the sixth altogether. So parentheses with an exponent just means take what's in the parentheses times itself. That same thing is true even if it's a binomial raised to that power. So let's take a look at what's happening here. 2x minus 5 to the power of 2 just means take 2x minus 5 times another 2x minus 5. And that's something we know how to do. So let's set up a grid. 2x minus 5 across the top. It's going to be another 2x minus 5 down the side. Multiply to fill your boxes. 4x to the second. 2x times negative 5 is negative 10x. 2x times negative 5 again is another negative 10x. Negative 5 times negative 5, positive 25. And then add everything up. 4x squareds minus 10x's minus another 10x's plus 25. Now, negative 10 and negative 10. Down 10, down 10 more. It's up to you to be very careful and know that that means you're down 20, so minus 20 x's altogether. If your x terms, your middle terms here, have the same sign, there's going to be x's left over in the end, so please be mindful of that. So take away from here, an exponent outside parentheses just means that what's in the parentheses gets multiplied by itself. Now, there's another little interesting pattern that sometimes happens, and I don't want you to think you've done anything wrong. Take a look at this first example, 3n minus 2, 3n plus 2. What's in the two parentheses looks the same, except that one has a plus sign and one has a minus sign. If that happens, there's a neat little pattern that comes to play. So let's take a look at these two examples. I'd like you to try the first on your own. So do a quick pause, multiply this out, and then unpause when you're ready to check. And 3n plus 2. All right. So if I fill in my boxes, this will be 9n to the second power minus 6n's plus 6n's minus 4. So if I now take what's in the boxes and add them up, 9n squared minus 6n's plus 6n's minus 4. See what happens. 9n squared, but oh my goodness, negative 6n's plus 6n's. Negative 6 plus 6 is 0. There are 0 n's, so we just don't even write them. And the minus 4 is then what's left. That's going to happen sometimes if this pattern occurs. If it's the same thing in the parentheses, except one's got a plus and one's got a minus, your final answer is going to have some things cancel to 0. It's okay. Just keep track of your steps and you'll be in good shape. Let's take a look at the second one, the one with decimals. It's the same way, but would you please do a pause, try it yourself, and then unpause when you're ready to check things out. So across the top, down the side, let's multiply. 5.3 times another 5.3 is 28.09, and y times y is y to the power of 2. 5.3 times 8.6 is 45.5. 5.58y's. Down here, 5.3 times negative 8.6 is negative 45.58y's. And then lastly, 8.6 times negative 8.6 is minus 73.96. So for my final answer, I'm going to take these four boxes, add them all up. So 28.09y to the second plus 45.58y's minus 45.58y's minus 73.96. And look at this, the same thing happens again. Those two middle terms are exact opposites. They add up to 0. So my final answer is going to have the 28.09y to the second, but that middle y term, 0 of them, doesn't even show up with the minus 73.96 on the end. So the pattern is a fun one. Just be aware that that does sometimes happen. So keep track of your work as you go, and you'll be in good shape.